Okay, today's lesson, we will look at the assignment, which is found on pages 268 to 271 in the section Combining Functions Graphically. We will look at the three questions in Assess for Your Understanding. So the first question, there are four parts to it, A, B, and C. You're asked to sketch the graph of a combined graph and then find its domain and range. So you have a sum, difference, product, and quotient. So that's questions. So A and B, we'll do the first part. Then we have C and D. Then question 2, very similar. And finally, question 3. So let's start with the first question. So the first question asks you to find a combined graph. And here we have a parabola, refers to f of x. And we have an equation, a straight line, g of x. So organize this better. You create a chart. We have x, f of x, g of x. So if we find reference point here, we have x is -2. And for f of x, when x is -2, y is 5. So I'll put 5 here for the y value for f of x. And the y value for g of x when x is -2 would be -1. So f of x plus g of x, so f of x is 5 plus minus 1. So you have 5 plus minus 1, give us 4. So our coordinates now will be x is 2 for f of x plus g of x, would be x is -2, y is 4. So we can plot that point right now to show you what it looks like, and I'll use a different color pen. So x is -2, y is 4 will be right here. Okay, let's continue plotting, arriving at our coordinate points here. So the next one we have x also g of x 0. So we have 0 minus 0 give us 0. So my coordinate point would be -1, 0. So we can right away we have -1, 0. That's my next point. And I can sort of connect these points here. I'll use a broken line to indicate that's my combined graph. And this graph is going up. So I'll indicate with an arrow. Then I continue the process. So now I have next point to be 0. And next be 0, -3. So we have 0 here. -3 for my f of x. And notice for the g of x, it is 1. So now I have -3 plus 1, which gives me -2. So my coordinate point would be 0, -2. And I continue the process. 1, -4, 2. So when x is 1, -4 here. When x is 1, 2. So -4 plus 2 gives me -2. So this would be -1, -2. So let's plot these points. So 0, -2, which is right here. Then we have -1, -2. Oh, sorry, it's 1, 1, -2. So it's 1 and -2. So we have our next point would be 1 and -2 here. Then we continue with the next point to be 2. So we have 2. We have -2 here. -3. And then we have +3. So you have -3 plus 3 gives me 0. So my coordinate point is 2, 0. Next is 3. So we have x is 3, 3, and f of x is 0, and g of x is 4. So in this case, we have 0 and 0 minus. So here we have 0 plus 4 equals 4. So my coordinate would be 3, 4. I can put coordinate 3. So we have 2, 0. Be right here. 3, 4. So we can continue. And I can do a fourth point here, 5, 5. But it goes on. If you were to 5 plus 5, 10. This point would be 4, 10. Now, it's way up the scale here. So that's my graph. So once I plot those points, my domain would be all the real numbers, because there's no restrictions. And the range, now this is approximately 2.25. I worked it out using a calculator. So y is greater than or equal to negative 2.25. So that's the first one. And the second one would continue the same process. Notice the x, it's a similar graph. G of x and f of x is the same graph as part A. So G of x and f of x, the same graph as in part A. So we can duplicate what we did in part A in part B. So we have, except now we are going to subtract. We have a difference. So I follow the same process as here. We have f of x, g of x. But here now we have f of x minus g of x. So my coordinate would be x, f of x minus g of x. So this is my new coordinates for my combined function. So you have -2, 5, -1. So now we're subtracting 5 minus 1. 5 minus -1 will give me 6. So let's write it here. 5 minus -1 give me 6. So it will be -2, 6. Then we have -1, 0, and 0. So we have 0 minus 0. And that will give us -1 and 0. So 0 minus 0 is 0. Next we have 0 minus 3, 1. Now this will be -3, -1 gives me -4. So my coordinate is 0 and -4. When we plot these points, later. So next point, 4, 2. So -4, -2 gives me -6. So 1, -6, 2, -3, 3. So we have -3, -3 gives me -6. So 2, -6. We have 3, 0, 4, which is 0 minus 4, -4. So we have 3, -4. And finally 4, 5, 5, which is 5 minus 5 gives me 0. This is 4, 0. Now I'll plot these points on my graph. So the first point I have here is 2 and -6. So -2, 6 here. Then -1, 0. So basically I'm connecting these points here. Next point is 0 and -4. So 0, -4 is here. Continue. Then 1, -6. Then 2, -6. So this graph of a vertex between -6 and -7. Then 3, -4. And 4, 0. So that's my graph. So my domain is X, so the real numbers, there's no restrictions. The range is approximately negative Y is greater or equal to -6.25. It's approximately 6.25. So this is finding a difference of two functions. The first one was a sum of two functions. Notice these graphs are the same. The original graphs are the same, just that and the D, we're looking at quotient. Now, they are all similar to our graphs. They're the same graph, except now you need to find different combination. So I'll simply use these values given already. We have them. So I've created a chart here. So it's the same as before, but now we are multiplying. So let's go back to what we had before. We have, in this case, we have a -2, 5, and -1. Once we have these points, it's very easy to calculate the combined functions, whether it's adding, subtracting, dividing, or multiplying. So -1, 0, 0, 0, -3, 1. Next point would be 1, -4, 2, 4, 5, and 5. Now, because both graphs have the same initial functions, I've combined the two of them. In this case here, I'm looking at a product. And In so the case, I'm looking at a quotient where I'm dividing. And here I have a column for coordinates for this graph here, which we have y equals f of x times g of x. So this is my y equal f of x g of x graph, and this would give me my y equal f of x over g of x. So let's work this through. So f of x times g of x, so we multiply these two here. So we know our x, by the way, will be -2 here. We can actually write it here, -1. This will be 0. And this will be 1, 2, 3, and 4. So we need to find our f of x, g of x. So multiplying 5 times -1, indicate it here, giving -5. So this would be my coordinate -2 and -5. Again, go up to my graph. So -2 and -5. That will be way down here, my first point. Then my next point is 0 times 0, which is 0. Then we have -3 times 1, -3. Then -4 times 2, -8. -3 times 3 gives me -9. 4 times 0 is 0. And 5 times 5 is 25. So let's go ahead and plot the rest of the points. We started off with 1, the -1, 0. Here's my next point. Use a pen for that. -1, 0. So this graph, my point. The next is 0, -3. So 0, -3. So this graph, there's a bounce. Then we have 1, -8. Continues. And 2, -9. So 2, -9 is right here. So this graph is actually, and then we have 3, 0. And 425 is way beyond the view of the graph. Notice that it's a cubic function. So the domain will be all except real numbers, and the range will be also all real numbers. So these are my coordinates for graph C. Now I go to graph D, and I'll follow through with this graph here. So let's complete the chart. So f of x over g of x. Now I'm dividing. So here we have 5 divided by -1. So 5, 1 will give me -5. Although, let me finish off first. So we have -2, -5. Then the next one, we have 0 divided by 0 here. Oh, well, we're into some trouble here because that's undefined. You cannot divide by 0. So it's undefined. So we'll probably have a hole there. So we have hole here, undefined, where x is equal to -1. This is undefined. Can I divide by 0? The next one we have here is we have -3 divided by 1. Give me -3. So my points here would be 0, -3. 1, 2, 3, 4. So -4 divided by 2 is -2. Then we have -3 divided by 3. Well, -1. We have 0 divided by 4 is 0. And the last one is 5 divided by 5 equals 1. So these are my coordinate points. Notice I have to indicate as a hole here. So now I go and plot those points and connect them with a nice smooth line or a straight and smooth curve. A straight line or a smooth curve. Let's see what we'll end up with here. So the first point is -2, -5. So -2, -5 is down here. Now the next one is a hole where x equals -1. So we leave that for now and we plot the other points to see what pattern there is. So 0, -3, which would be here. So notice I am going to connect. So this would be my hole right there, where x equals -1. Continue 1, -2. And 2, -1. 3, 0. 4, 1. So there's a hole at y equals -4 and x equals -1. So now we have a restricted domain and range. So it's a straight line, so it would be all of the x except where x equals -1 and the range where y is not equal to -4. So that's my domain and range for that graph. Okay. Okay, let's go on to question 2. Question 2 asks the first part, say the domain and range. So the domain and range for fx and g of x. Now f of x begins at x is -2. So for f of x, we can say the domain where x is greater than or equal to -2. The range be from 0 to infinity because it doesn't go below y equals 0. So we can say y is greater or equal to 0. Now g of x, which is a straight line, which is a negative slope, the domain, no restriction. So we say x is a set of real numbers, and the range also a set of real numbers. Now they ask us to graph the product of these two functions, and I've created a chart, and I've already indicated my reference points. So x is -2, y f of x will be 0. G of x would be 8. So 8 times 0, 0, so my point would be -2, 0. -1 is my next point, f of x is 1. And we have it as being 6, 1, be 6 here. Okay. So 1 times 6 is 6. So my point here is -1, 6. Now x is 0, f of x is approximately 1.4, 1.5. I would say 1.4. G of x is 4. So 4 times 1.4, approximately 5.6. So we can say x is 0, y is 5.6. Next, we have x is 1. So f of x is close to 2, but I would say 1.7 approximately. So this is approximately. And 2 is g of x. So 2 times 1.7 gives me approximately 3.4. So 1, 3.4 is my coordinate point. And the last one is 2, 0. 0 here, 2, 0. And we can try 3, which is just over 2. So I'll say 2.2. And g of x is -2. So 2.2 times -2 gives me -4.4. Gives me a coordinate of 3, -4.4. Now I'll plot these points on my graph. So I have my 2, 0, which is right here. The graph begins from here to -2, 0. Then you have -1, 6. So we can connect them. I'm using a broken line just to make it clear, but it should be all connected. Then I have 0, 5.6, which is approximately here. This is parabola is coming down. Then 1, 3.4, which is 2, 0. And then 3, -4.4, which is out here. So So that's our graph, which is y is equal to f of x times g of x. Now the final part of this question, part D. So what is the domain of f of x times g of x? So f of x times g of x, the domain is from -2 to infinity. So we can say that the domain of y equals f of x times g of x is x is greater than or equal to -2. Now the other part of the question, how is it related to the domains of y equals f of x and y equals g of x? Well, the graph of y equals f of x times g of x does not extend to the left of x equals -2. So we can say here the graph of y equals f of x times g of x does not extend beyond x, or to the left, I should say, to the left of x equals -2. As you can see from your graph, right, this graph actually begins from -2 and goes to the right, doesn't it? Doesn't go to the left of it. Okay, and we have one final question, question 3. So similar to question number 2, so they ask you to find the domain and range of f of x. So this is my f of x. So it begins where x at the origin 0, 0. So we can write here domain x is greater than or equal to 0. And the range, so the range is starting from 0 going up to infinity. Y is greater or equal to 0. And g of x, now g of x looks like it's an absolute value. So domain be all of the real numbers. Okay, there's no restriction going to the left, goes to the left and right. So goes to the left and right. And the range is all the values above y equals 0. So the next part asking you, so without graphing, determine the range and domain of this function and justify your answer. Now, the domain of h is the same as the domain of f of x. So if you look at h of x here, so it's the same as the f of x, because x cannot be negative. So if you look at this graph here, x cannot be negative for f of x. Now the range of h of x is the same as the range of f of x and g of x, because y has to be greater than 0. So I'll put those into words. The domain h of x is same as the domain of f of x, because x cannot be negative. So f of x, oh, can't see there, f of x cannot be negative because the domain is from 0 to infinity. In other words, x has to be greater than or equal to 0. The range of h of x, notice the range is from 0 to infinity. So the range of h of x is the same as the ranges of f of x and g of x. In other words, all real numbers greater than or equal to 0. In other words, y must be greater than or equal to 0. So let's see how right we are, and then we are going to ask us to sketch the graph of h of x. So we want to sketch a graph of f of x plus g of x using our coordinates here. So here we have x is 0, and we'll do each one separately. So x is 0, and for f of x is also 0. So I'll have to adjust my screen here so you can see the whole picture. Okay, so x is 0, y is 0 for f of x, and for g of x is also 0. So 0 plus 0 is 0. So my point here is x is 0, y f of x plus g of x is also 0. So I can plot the point here, point number 1. So we have x is 1, f of x is 2, oh, sorry, 1, and g of x is also 1. So 1 plus 1 is 2. So my point here is 1, 2. Now x is 2, y is approximately 1.4, it's just below 1.5. I won't argue if it says 1.5. And g of x is 2. So 2 times 1.4 times 2 gives me 3.4. So 2, 3.4. Then we have 3, x is 3, y is 1.7 for f of x, and for g of x is 4. So 4 times 3.7 will gives me 4.7. Oops. Actually, it should be 3. So let's go back in 3. Yes, 3. Give me 4.7. So the points is 3, 4.7. And the last one, x is 4, f of x is 2, and g of x is 4. So 4 2s are 6. So we have 6 here. So my point would be 4, 6. So now we plot our points. So we have first is 1, 2. Second point is 1, 2. Third point is 2, 3.4, which is about here. So we connect to a point now. Oops. X goes 2, 3, 4.7, 4, 6. Continues. So this is the graph h of x equals f of x plus g of x. As you can see from here, the range is from 0 to infinity, and the domain is from 0 to infinity. So I'll post these on the blog. So if you want to look at the notes in PDF format, I'll post these later.